Hi, my name is Oz Katz. I'm the CTO and co-founder of Treeverse, the company behind lakeFS. So in this walkthrough, I'm going to show you what lakeFS is, what problems it tries to solve, and also try to do a quick demo to show how it works. So what is lakeFS? So lakeFS tries to solve the manageability problems of modern data lakes. So defining data lake for a second, it's a data architecture which puts usually some centralized storage at the center. Usually this would be something like Amazon's S3, Google Cloud Store, Azure Blob, any type of object storage typically, where all the organizational data is being streamed or ingested into this central location where it's available for everyone to do analytics, to do machine learning and data science, to do reporting. Once it's all in one shared, scalable, cheap location, we can then think of all different kinds of use cases we can then employ over it, where the time to value is very, very quick. Another way to look at this is kind of like a shared folder, right? It's very cheap, it's very scalable, but it's a shared folder. So trying to provide any type of like production safety on top of this is a very error-prone environment. Trying to do governance or privacy regulations of any sort is really, really difficult because it's one place where everyone stores all their data. It's accessible to everyone. It's really, really hard to manage, especially if we have a lot of different readers and writers for the data. So this is what lakeFS tries to solve. The way it's implemented is that we define lakeFS as kind of like a layer that provides Git-like capabilities on top of an object store. So we're API compatible with the S3 API, so it works with all the different data tools that support S3. The underlying storage could be basically any type of cloud object store. We support all of them. And we add a layer of Git-like semantics. This gives you the ability to work on an isolated branch. So think about taking your entire data lake, petabytes in size, do create branch, and you get your own isolated environment to experiment on. And then if you want to run jobs that you want to eventually merge your output to production, you define a set of hooks which give you validation before merging. So stuff like data quality checks, schema validations, you can run all of those before actually atomically merging your data into a main branch or a master branch. So jumping quickly into a demo, let's see how this works. So I've went to docs.lakefs.io. Again, this is an open source tool, so if I go to Quick Start, there's an installation guide, which is basically a one-liner if you have Docker installed. For this demo though, let's take an environment that I already have on AWS. So here I have a repository called Demo Data Lake, where the data is actually stored back to S3. So if I go here, I can see that this is my repository. I'm under the main branch right now, so this is prefixed by the name of the branch. And I have a TSV file. So let's try to read this from Spark using Jupyter. So this tries to read from an AWS branch. Again, this is the prefix, which doesn't yet exist. So let's create it for a second. So I go under branches, do create branch. I call this AWS demo, and it's derived from main. So this is metadata only. I didn't copy any data by creating a branch. So lakeFS does copy and write for branches. So going back to my example, if I just execute this, it's going to take a few seconds, and I'm going to get back a data frame showing the data from this table. Very nice. Now let's try to do something useful with it. So let's do df write ORC. So I'm going to try to write an ORC table. This is just a columnar format. I'm going to store it back to S3A. Again, this is our lakeFS installation. So I'm just going to take this with the branch name, and I'm going to write it to production / columnar / IMDb. Just invented some location. I'm going to execute. It'll take a few seconds. All right, this is done. So if I look at the lakeFS installation and I go in and see the uncommitted changes for my branch, So no changes on main because we work on an isolated branch. If I go to AWS demo, I can see that I have an ORC file here. So let's actually commit this. Let's say row IMDb data as ORC. And I can add arbitrary metadata fields. So for example, let's say the Spark version that I used. This could be anything that we care about for reproducibility. And it's committed. So looking at the commits, I can see that I have my ORC changes. Now let's try to merge them. Let's try to do something interesting. So let's say I want this ORC information to be on my main branch. So I'm going to say that I want to merge AWS demo into main. It's going to show me the changes that I've made between those two branches. And when I try to merge them, I see that it fails. And it fails because there is an action that failed. This action is called Parquet only in production. So the name kind of implies what happens. So if I take this run ID and I go to actions, I can see that I have a failure here. And this failure actually says file format not allowed. So the ORC file is not allowed under production. So what we can do is we can go back and fix the problem. So only Parquet is allowed. Let's write it as Parquet instead. So I'm going to go to, as you can see, main doesn't see this change at all. If I go to AWS demo, production, columnar, IMDb, let's delete those files. All right, it's not here anymore. And this time, let's write it as Parquet. This is allowed. So this is going to take a few seconds. All right, this is done. So going back, let's see the uncommitted changes now. I see that I deleted ORC and added Parquet instead. Let's commit this. Again with Spark version. Let's do compare again, choosing main and my AWS demo branch. Now I see I'm trying to merge Parquet files. This time the hook succeeds. This is allowed, and if I go to the main branch, I now see that I have my Parquet files there. All right, so this was a quick demo of lakeFS. To learn more, check out docs.lakefs.io or visit us on GitHub at github.com/treevers/lakefs. Thank you very much.